In this video, I will cover material on various weather phenomena that frequently appears on the FAA Part 107 exam, such as atmospheric stability, air masses, and fronts. A lot of the material covered in this video is similar to that in the study guide I used to prepare for and successfully pass the FAA Part 107 exam with a 90% score. Also, there are many other YouTube tutorials I made to help you prepare for the exam. I linked all of these resources in the description. The main source of weather on Earth is the sun, so any weather process you can think of is the direct result of uneven heating of the Earth due to sun rays hitting the Earth's surface at varying degrees. This creates air circulation, called wind as we know it. For the weather topic on your FAA Part 107 exam, it is important to understand the properties of cold and warm air. Cold air tends to be denser, heavier, and has higher pressure than warm air. This is so because air molecules under high temperature have higher energy and tend to spread out for a given unenclosed cubic meter of volume. Since there are fewer molecules in warm air and more molecules in cold air for a given unenclosed cubic meter of volume, warm air typically rises, while cold air tends to sink. Therefore, warm air would create low-pressure events, while colder air would create high-pressure events. Next, different surface areas emit heat to a different degree, which creates convective current, that is, a small area of local circulation, which may cause turbulence at times. For example, sand, bare land, and urban places tend to emit a lot of heat, causing updraft air circulation. Lakes, rivers, trees, and other vegetation typically absorb and hold on to the heat, which may produce downdraft air circulation. Let's check your knowledge with a few questions. The first question is about how weather events occur. Because we know that uneven heating of the Earth by the sun produces various weather processes, the answer is C, which is heat exchange. Answers A and B are incorrect because they are the consequences of unequal heating and not the causes of weather. The next question tests your knowledge on the source of thermals. Thermals are small-scale currents of updraft air produced as the surface of the Earth is heated by the sun. So, knowing this, we immediately see that the answer is C, which is solar heating. Choice A is incorrect because thermals are updrafts and have nothing to do with counterclockwise direction. Choice B is interesting. Temperature inversion happens when cold air moves in and concentrates at lower altitude, while the air above it is warmer. In other words, temperature inversion occurs in a vertical layer in the atmosphere, where the ambient temperature increases with altitude. Because cold air tends to descend, while warmer air tends to ascend, temperature inversion creates a relatively stable air mass, since there is little, if at all, the movement of air, making thermals impossible. Therefore, choice B is incorrect. The next question wants to know which areas on the map will produce the most amounts of thermals. Remember, a thermal is an updraft air current typically produced by barren terrain or sand. We also know that areas with a lot of water are poor sources of thermals and typically cause downdrafts. Looking at the map, we can see that areas 5 and 7 are both located above the water, which is unlikely to cause a thermal. Area 2, on the other hand, is located on land. Even though there is a lake and a swamp at Area 2, it is still much likelier to be a source of a thermal, making choice A the answer. The next topic is wind. Wind can greatly affect your drone performance. If there are obstructions on the ground, this may change not only the speed but also the direction of the air current, causing a dangerous condition for the unmanned aircraft. Also, strong winds can impact the ability of a drone to maintain its position and consumes battery power faster than expected. Also, consider a building. If the wind blows into the building, it may create a strong updraft on the side that faces the wind. However, the other side of the building will have downdrafts. The same logic applies for mountains or any other tall obstruction. Let's answer a few questions. This question tells you that there is a strong wind from the north and you are in an open field with no obstructions and will fly your drone to the south of your location. The question wants to know which of the following is not a concern for your drone operation. Because there are no obstructions in the field, this means that turbulence is very unlikely. However, we know that strong winds can consume a drone's battery and make it hard to recover. This excludes choices A and C and makes B the answer to this question. The next question asks you where wind shear would exist. Wind shear is a change in wind speed and/or direction that occurs in a sudden manner. This can cause major issues for drone operations. Wind shear can occur at any altitude. This makes choice A the answer to this question. The next topic we will cover is air masses and fronts. Air masses are in constant motion. When an air mass with certain characteristics, such as temperature and moisture, advances on an air mass with different characteristics, the division line between these two air masses is called a front. There are two important concepts to define. First is trough, which is an elongated area of low pressure. Troughs are associated with colder air and low pressure aloft. Because there is a low pressure in the air mass up high, the air tends to rise to the east of the trough, creating unstable weather and precipitations. Sometimes wind develops around a trough's low pressure center that blows in a counter-clockwise direction. Ridges are elongated areas with high pressure. Ridges are associated with warm air and high pressure aloft. Because the air aloft is heavier and exerts higher pressure on the air mass below, it creates a stable atmosphere. This produces dry, sunny weather conditions underneath the ridge. Sometimes winds form around a ridge high-pressure center that blow clockwise. As previously defined, fronts are division lines between two air masses with disparate properties, and typically temperature is the most important one. You need to remember that all fronts lie in troughs. Each air mass has its own highest pressure center. As you move away from that center, the pressure tends to go down. As two different air masses with different temperatures collide, they do so at the periphery, away from their respective pressure centers. That boundary where they collide is a front, and it will lie in low pressure areas, or troughs. As for the fronts, there are several types of them. For the FAA Part 107, you need to know the associated weather conditions that occur with each type. A cold front is the leading edge of a cold air mass that advances on a warm air mass. Because cold air mass is denser than the warm air, the approaching cold air will slide under the warm air, causing the warm air to rise rapidly and abruptly. As warm air rises, it cools down, resulting in condensation and formation of thunderstorm cumulonimbus clouds, which cause severe weather conditions. These cumulus-type clouds will have a tall vertical structure that is conducive to formation of thunderstorms. Cold fronts tend to move quicker compared to warm fronts and are associated with thunderstorms, showery precipitations, turbulence, and hazy visibility. As a cold front passes by quickly, the visibility improves and becomes clear. A warm front is leading edge of a warm air mass approaching a cold air mass. Because a warm air mass is less dense than cold air, warm air will wedge above the cold air and advance very slowly for longer periods of time and for hundreds of miles. As a result of this gradual process, more flat or slightly layered stratiform clouds will form with calm and steady long-term precipitations, a long-term period of reduced visibility, and calm air. These are the symbols that denote various weather systems that we talked about. Here you see several other weather phenomena I didn't describe. A stationary front is a boundary between two air masses of different temperatures, and this front does not move. Because neither the cold nor warm air mass dominates one another, some warm air mass is lifted above the cold one, and there could be some light precipitation. An occluded front typically forms when a warm air mass gets squeezed between two cold air masses advancing from both sides. As the two cold air masses converge on each other, the warm air mass gets pushed up and occluded or cut off from the ground. That is where the name comes from. Occluded fronts are associated with strong winds and heavy precipitation. Finally, squall lines are narrow bands that form along or ahead of a cold front. Squall lines are typically associated with violent high winds and severe thunderstorms and are very dangerous. As the front passes, a frontal passage will have the following typical characteristics or discontinuities: a temperature change, steady decrease in pressure followed by an increase in pressure as the front passes, and changes in wind speed or direction. Let's go over a few test questions on air masses and fronts that can show up on your FAA Part 107 exam. This question asks you to identify the most recognizable discontinuity across a front. Choice B is incorrect because cloud coverage is not a necessary condition to exist across a front. Similarly, choice C is incorrect too because changes in relative humidity are not easy to recognize across a front. This makes choice A the answer because temperature changes are indeed one of the most reliable indicators for a frontal passage. The next question tests your knowledge of the definition of ridges. If you recall, ridges are elongated areas of high pressure. This makes choice C the answer to this question. The next question is about fronts and their location. As explained earlier, fronts are located at the lowest pressure zone where two air masses collide with each other. Troughs are low pressure areas, therefore fronts are always located in troughs, making choice C the answer. The next question asks you about one weather phenomenon that is always present when flying across the front. You can immediately discard choice B. This is so because precipitations may not be necessarily present in a front. Also, there could be stability across two colliding air masses that form a front, making choice C incorrect. However, change in wind direction is always present across a front, making choice A the answer. The next question tests your knowledge of cold fronts and weather phenomena associated with them. We know that cold fronts cause the most severe changes in weather, especially thunderstorms, heavy rain, turbulence, and relatively good visibility. Warm fronts are characterized by long-term periods of reduced visibility and steady precipitations. So we can immediately see that choices A and B are relevant for warm fronts, while choice C is relevant for cold fronts, making it the answer. The next question wants to identify the best flying conditions. We can immediately discard choice C, as turbulence is terrible for flights. Choice A is incorrect because warm, moist air has few air molecules in it and contains a lot of water vapor, which is not good for flying. Cold, dry air, on the other hand, is denser and contains more air molecules compared to warm, moist air for a given volume. Also, cool, dry air is very stable and resists vertical movement, making it perfect for flying. This makes choice B the answer. The next question wants to know the name of the zone between two different air masses of temperature, humidity, and wind. From before, we know that such a zone is called a front, and temperature, humidity, and wind will often rapidly change across the front. This makes A the answer. Choices B and C are incorrect because wind shear is a separate weather phenomenon that has nothing to do with the name of the zone the question is asking about. Also, air mass has relatively uniform properties of temperature and moisture, which makes choice B incorrect. The next question wants to know which thunderstorm produces the most hazard for an aircraft. From before, we know that warm front thunderstorms are relatively mild, which excludes choice C. Steady-state thunderstorms, by their definition, are stable precipitations that are not very dangerous. However, squall lines are narrow bands that form along or ahead of a cold front and are very dangerous for flying. This makes choice A the answer to this question. The next topic is atmospheric stability. While we covered it a little bit before, there are a few specific characteristics to remember though. Atmospheric stability is the resistance of air masses to vertical movement. So a stable atmosphere would resist downward or any upward movement. When there is an unstable atmosphere, downward or upward movement is possible, which can give rise to a convective current or wind. The atmospheric stability can be determined by how temperature changes vertically with altitude compared to some standard. This measurement is referred to as temperature lapse rate. Lapse means a gradual fall, since typically temperature falls with altitude. While you do not need to know any formulas for your FAA Part 107 exam, the exact process of determining atmospheric stability is this. First, you measure the environmental or actual temperature lapse rate for a given parcel of air at a given location. Then you compare the actual temperature lapse rate with a dry adiabatic lapse rate, which is a theoretical temperature change of a dry parcel of air as you lift it fast in an adiabatic process, meaning no heat is exchanged in the process of lifting. The standard dry adiabatic lapse rate is 5.5 degrees Fahrenheit or 3 degrees Celsius per 1000 feet, meaning the temperature falls by 3 degrees Celsius for each 1000 feet. If the actual temperature lapse rate is less than the dry adiabatic rate for an unsaturated air parcel, atmosphere is considered stable because vertical motion of an air is damped. However, if the actual temperature lapse rate is greater than the dry adiabatic rate, there is atmospheric instability and vertical motion is possible. The reasoning behind this is that as temperature falls faster compared to adiabatic standard, there are air masses stacked on top of each other with high contrast in temperatures. This would lead to higher possibility of vertical movement and thus instability. Of course, in reality, you will have moisture present in the air. For this reason, there are formulas that make corrections for humidity when determining atmospheric stability. If there is anything you need to remember from this slide, is that atmospheric stability is determined by measuring the temperature lapse rate. The ideal condition for atmospheric stability is temperature inversion, where a warmer parcel of air is situated above cold air, making the ambient temperature rise with altitude. Conversely, warming from below would decrease the stability of air. The typical conditions for stable versus unstable air are shown in this table. Note how these two columns correlate with conditions characteristic of cold fronts and warm fronts that we covered before. Let's go over a few questions here. This question asks you to identify the characteristics of a stable air mass. We know that stable air is associated with steady precipitations and smooth, calm air. This rules out choice A and B. On the other hand, poor visibility is one of the characteristics of a stable air, making choice C the answer. The next question tests your knowledge of unstable air mass. We know that unstable air mass is associated with turbulence and showery precipitations with occasional thunderstorms. This makes choice A the answer. Choices B and C are wrong because these are characteristics of a stable air mass. The next question wants you to know which measurements would determine atmospheric stability. Recall that the difference between the actual temperature lapse rate and adiabatic lapse rate determines the stability of an air mass. This makes choice B the answer. Other choices cannot determine the vertical stability of an atmosphere. The next question wants to know which factors would reduce the stability of an air mass. Let's examine incorrect choices first. Choice B is wrong because cooling from below means that the air at the surface would become denser and therefore resist upward movement, making the air mass actually more stable. Next is choice C. Recall that if the water vapor or humidity goes up in the air, it becomes less dense and prone to vertical movement. So an increase in water vapor would decrease atmospheric stability, while a decrease in water vapor would actually increase atmospheric stability. This makes choice C incorrect. Choice C would have been correct if it was phrased increase in water vapor. On the other hand, warming from below would make an air mass at the surface less dense and prone to vertical movement. Hence, atmospheric stability goes down with it, making choice A the answer. The next question tests your knowledge of the characteristics of an unstable air mass approaching the flight location. We know that unstable air masses are associated with thunderstorms, turbulence, and cumulus clouds. This rules out choices A and C. But because stratiform clouds are present under stable atmospheric conditions, this makes choice B the answer. The question states that there is a low-level temperature inversion with high relative humidity present. You need to identify weather conditions that can be expected in this case. Temperature inversions are associated with stable air conditions with characteristics such as smooth air, poor visibility, fog, haze, and perhaps low stratiform clouds. This is so because with temperature inversion, the temperature of the air rises with altitude and you have layers of smooth, stable air close to the ground. Under the inversion conditions, temperature will rise up to a certain point though. Thus, air at the top of the layer where temperature inversion will stop acts as a lid, keeping various weather and pollutants trapped underneath. With relatively high humidity, cloud formation is possible closer to the ground, and you will have fog, haze, smooth air, and poor visibility. This makes choice A the answer. As for the other choices, choice C is incorrect because it mentions turbulent air, which is not a characteristic of a stable air. Also, choice B is incorrect because you are unlikely to have wind shear under stable air conditions. This is it for today's tutorial. In my next tutorial for the FAA Part 107 exam, I will cover other topics related to weather, such as thunderstorms, visibility, clouds, icing, and fog. Feel free to ask any questions if you need clarifications for the material covered in this video in the comments. If you found this video helpful, please give it a like and subscribe to our channel. We will have more tutorials that will help you prepare for the FAA Part 107 exam. We also regularly post travel guides and photography tutorials. Thanks for watching.